Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by SUSE. My name is Cody, and welcome back to Techstrong Learning. We have an exciting program ahead, but first, I have just a couple of housekeeping notes I'd like to review. First of all, we are recording today's session. So if you miss any of our conversation, or if you'd like to just simply rewatch or maybe share with your team, you will be receiving an email with a link to access the recording on demand shortly after we conclude our live session today. Now, if you want to engage with us, there are a couple of ways to do so. The first and the easiest option is the chat tab. I believe it's on the right side of your screen. So if you see that chat tab, I'd like you to let us know from where in the world you are joining us. I'm seeing Australia, Brazil, Germany. So we've got a worldwide crowd and we want to get a sense of where everyone is. Now, if you have any more general comments or discourse you'd like to have with the rest of our audience, that's going to be for the chat tab. If you have questions for our speakers today, we do want you to direct those to the Q&A. Sending those questions to the Q&A just helps us keep track, and we do want to address as many of your questions as we can today. We've got plenty of time set aside at the end for that. Additionally, before we close things out today, we are giving away 4 $25 Amazon gift cards, so be sure to stick around until the very end to see if you're one of our lucky winners. So our topic of conversation is verifying the security of your Kubernetes clusters, and I'm joined today by Holger and Dieter. They're both from SUSE. So Holger, Dieter, thank you both so much for joining us here on Techstrong Learning. Holger, do you want to go ahead and take it from here? Take us into this presentation.
Yes. So first of all, let me introduce myself and let me thank you to everybody to join our session today. So my name is Holger. I'm based in Germany. I saw already some people are from Germany as well. I joined NewVector before the acquisition by SUSE. Maybe you are aware of it. If not, let me explain. So NewVector was a startup company based in Silicon Valley, San Jose, if I recall right. And we got acquired by SUSE in October 2021. And we worked as a team. Dieter, who will do a more deeper technical session, and what I will present first is a few slides to explain what use cases you can cover with NewVector. That helps always for the later demo of the technical session. So as Cody said, for your deeper questions, let's wait to the end for the Q&A session. And but in between, if you want to send some comments, use the chat and someone will take care about it. Okay, let me start. So first of all, that's why I always start with this more marketing slide that shows where NewVector solution is coming from, because that explains the idea of our founders from NewVector. And that was back in 2015, where container environments becoming more relevant for more agile development of applications. And many people at that time tried to use traditional security tools to use it like they were used to in traditional network environments, but they found out it does not work. And that is what our founders identified as well. And that is how it started, that they developed NewVector. And why I'm telling you that, it's not only because to tell you a nice story, is because the tool is designed for giving back the network visibility like people were used to in the traditional network world. And so this tool is designed for sitting inside the container infrastructure itself to get the ability to read the network traffic in clear text on protocol level. And that gives us capabilities other solution providers don't have. And that shows where we are coming from. I'm not used for the tool, but now I have. So Mainly, you can cover two main use cases for container security. So this is a classic CVE scanning for images for DevOps teams, from pipeline to registry, and also the productive environments. We provide as well some compliance reporting for certain regulations. You can name it CSI, benchmarking, GDPR regulations, NIST, HIPAA, and so on. So this is where CISOs always are smiling because they get their check mark from compliance checks. And the second main use case, and that's why I explained the first slide before in a bit more details, that is the strength of NeuVector. We are able to read the network traffic inside the container infrastructure based on layer 7 on protocol level. And that gives us the ability to learn the application behavior automatically. And with that capability, we are able to build certain microsegments of that application behavior. And so we can realize in real time every single anomaly. So a potential threat, zero-day attack is an anomaly, and we can act on that. And that prevents you against zero-day attacks and data losses. And that's one reason what gives us the capability is sitting inside the container infrastructure itself. And that's why I explained so deep about it in the first slide. So this is a Gartner slide. There are two reasons why I would like to show you that is, of course, if a researcher like Gartner talks good about us, of course, we would like to let you know. But the main reason is that is what Gartner recommends if you consider to implement container security control, and it explains very well where NeuVector can help. As I said, that's layer 7 microsegments we can build automatically based on the behavior learning, and that gives the control of the application behavior, and we can act inside the container infrastructure like a traditional web application firewall. So if there's an unwanted network traffic, we can block that, like you know from traditional next generation firewalls. And in addition, the classic CVE vulnerability management we can do as well, like I explained in the use case slide before. Again. And that is in a bit more detail, the vulnerability and compliance management. So as soon as a developer creates an image, put it on CE/CD pipeline, we can scan it. And NeuVector is a very neutral tool. So even we got acquired by SUSE, we will continue as a neutral tool. We can integrate most of the standard pipeline tools as well as most of the registries. So if you heard about the SUSE acquired Ranger as well, it's not the case that we are supporting Ranger only. Most of our customers today, I would say 90% are OpenShift customers. And so if a developer put the image on the registry, we can scan that in addition, and as well also in the productive environment, so during runtime. And in addition, we provide also some CSI benchmarking. So again, I need to emphasize on it, as we are sitting inside the container infrastructure using the Kubernetes APIs itself. So we don't create an overhead of performance, or you don't need to install an agent or change anything on the application. As said, we are using the Kubernetes APIs itself, and that's is one reason why we are fast and accurate in scanning. And we can scan more than thousands of images in parallel. We got compared against other solution providers as a big US hyperscaler, and others failed much earlier. And it's not that I want to point to others. It's to explain the reason why we are fast and accurate, why we are scalable, is because we are using the Kubernetes APIs itself. So it's easy to deploy. That means if you want to implement NeuVector to your container infrastructure, you don't only need to download the NeuVector image from our Docker hub and put it on your registry and deploy it like an additional app. So sets it, and immediately the solution is running and give you, after a few minutes, the first results and give you a good overview about how your security in the container infrastructure looks like. And as we are sitting inside, so we are an on-prem solution, it's not a SaaS solution, no traffic to the outside world is needed. So that means that you can use it in a fully air-gapped environment. And that's, for some customers, is even a mandatory requirement. Again, a list of all use cases you can cover. That's a vulnerability and compliance checks for images from pipeline to registry. Some admission control capabilities. One small example is root access. You want to avoid, of course, that not every administrator can access every container with root access. Vulnerability and compliance check even in productive environments. So, and we can give you full visibility of the network traffic, and with the deep packet inspection capabilities, what is patented, we understand every network process, service, and when the application accesses files based off the application behavior. And so we realize every anomaly out of it, and that protects you against zero-day attacks and insider attacks. And as that application behavior learning is automatically and gives you a first policy how your cluster should look like, that we said you can create every security policy automatically as soon you like to roll it out to other containers. So from my point of view, it's a quite good example what explains the difference between scanning and real-time traffic inspections. That's why I'm showing that always. Virus scanner capabilities is you need to know first the vulnerabilities, and you have to write a signature or pattern, and you have to roll it out. And you need to have that knowledge about that vulnerability before you are able to do that. And the difference between real-time traffic inspection is that you realize every single action, what can happen in real time, and you can act on that. And that is what you are able to do with NeuVector inside the container infrastructure. That's why I would like to explain in a bit more detail. So we act inside the container infrastructure like a traditional network tab. As said, we can read it based on layer 7 and understand every traffic from east to west, from ingress to egress over all clusters, and that gives you the full visibility. And with the deep packet inspection capabilities, we can prevent against data losses. Small example only to explain it: if from one pod to the other pod with a certain protocol only in one direction, a file access happens on a database, and suddenly another protocol appears, maybe also in the other direction, what shouldn't be the case, that is a potential attack. We realize that in real time, and we can block that. And that is a big advantage of that runtime security. How we do that is, as soon you install a NeuVector, as I explained, download the image from Docker Hub, deploy to your container infrastructure, and after that, the software is running immediately in the so-called discovery mode, identify everything automatically, and you will get first results in minutes. After that, depending on how many applications you have, how complex your infrastructure, or how big your infrastructure is, it can take a few hours, and then you can turn the software in the so-called monitoring mode. And as soon as an anomaly appears, we create alerts, and you can integrate that alerts into your SIEM system and take actions from there, like you're used to do it. And important to mention is that nothing happens until monitoring mode. So no blocking happens, because it is a question what very often pops up, because people are afraid that you can block traffic what creates false positives. But that we can avoid with the monitoring mode, but you can switch the software also in the so-called protect mode, and as soon an anomaly appears, it can get blocked. The alert will be created in addition, and that is integrated into SIEM as well, but you can block it. And it must not be on every single application. You can do that for every single service and process. That you will see later in more details in the technical demo. And as said, every security policy you can also replicate and install automatically to all other clusters with tool like YAML. So that is how the dashboard looks like. Here's a bit hidden because of that tool. What created the PowerPoint a bit different, but you will see it in the live demo as well. So the blue arrows are the usual behavior, and it's like it should look like. The red arrows are an unusual behavior. You can go with the mouse there, and it explains why we consider that is an unusual behavior. That can help developers as well to improve the development of the application. Or if you are working in protect mode, it will block that unusual behavior. With the acquisition of by SUSE of NewVector, the software got open sourced. If you know SUSE as a company, SUSE is a fully open source company. You can download, as said, the image from Docker Hub. The documentation is also public, and you can try it out. And what you will get if you purchase subscription licenses is maintenance and support, and also some predefined web and DLP WAF security policies. Log4j is a good example about it. If you recall about the situation with Log4j, it was a real horrible time for security teams. What we did is we created a policy after a couple of hours, and all our paying customers could download it, upload to the system, and they got fully protected against the Log4j threat. Yeah, that's mainly from my side. As I said, yeah, Dieter is here. He can introduce himself, but what I would like to ask you, if there are any questions in between, let us know, or wait to the Q&A sessions. And I try to answer the questions during Dieter's presentation in the chats.
So let me continue. My name is Dieter Reuter, also from the SUSE NewVector team. And I'm working since about 6.5 years in this container security area for NewVector. And I would like to show you a little bit in a live demo how all these things working. So Holger has right now more focused on the runtime features about analyzing network traffic. But let's go a little bit back to the topic of this webinar, verify the security of your Kubernetes clusters. And I would like to show you how easy it is just to analyze your Kubernetes cluster. We had a couple of questions in the meantime on the chat, and it's more about, does it run in a specific environment? So yes, NewVector is working on all different kinds of Kubernetes systems, branches, OpenShift, even in a pure Docker environment. It works because it's just containers only. But the best thing is you're running in a Kubernetes system like Tanzu, or in the cloud, Azure AKS, on Google, on AWS. So everything is supported. And if you have questions, I think we have time for later in the Q&A. So let me first share my screen. And here what you right now see, this is a login screen to our software, and everything what we install, it's installed directly in your cluster. So if you're running a local cluster on OpenShift or on Tanzu, you have a pod running behind it which drives this UI. And I would like to walk you through a couple of basic features what you can get out of this solution. So normally you deploy it, and it takes literally maybe 10-15 minutes. You can install it with a YAML file or a Helm chart or with an operator. But the interesting thing is what do you get out of it? So as soon as you have deployed it, you log in and you have a view about the platform itself. So as I said before, it's Kubernetes is supported, Rancher, OpenShift, all kind of those stuff. And what we are doing is we connecting directly to the Kubernetes API. We are reading the version number. We are reading some other details, so we can show you if there are any CVEs inside of that current version of this specific Kubernetes system. So here in this case, this is running on Google Cloud. Everything is fine. But if I switch in a different one, let's see if it works. Yeah, this is, for example, on Azure AKS. You see different version of Kubernetes, and we were able to detect a CVE. So this is really easy for us. Just from the version number of Kubernetes, we can just show you if there are any known CVEs baked in, and you get a recommendation maybe if you should upgrade to a newer version. So that's one thing. The next thing, let me switch back to my first cluster, is we analyzing all the worker nodes. So for the worker nodes, you see here a specific operating system running. It's COS from Google, running on Containerd as a container engine. We also support, of course, Docker engine and CRI-O. We do a full compliance check on those worker nodes, but compliance check in form of a CIS benchmark for specific for a containerized environment. So we support Docker CIS benchmark, Kubernetes CIS benchmark, and of course OpenShift CIS benchmark. Then let's switch back to the next cluster. If we go into vulnerability scanning, and this is something we easily provide a full scan for known vulnerabilities directly on the operating system of the worker nodes. So here in this case, you see there's an Ubuntu system used. We are supporting Debian, all other classic systems, everything from SUSE, everything from Red Hat, even Oracle Linux is supported, and so on. And what we are doing, we are just looking up in the file system of the worker nodes, see what operating system is running. From now on, we know the package manager. We're asking, hey, give me a list of all the installed software modules and their current running versions. And we compare these exactly to our CVE database. And later on, we can even tell you if there are any CVEs which you can easily mitigate. Here, for example, I'm switching to a AWS EKS cluster. And here you see a couple of vulnerabilities which were detected and there is already a fix in place. So this is for you guys in the operating team, an easy reminder, hey, just upgrade the operating system on the worker nodes. So as I said, all those features are just coming out of the box without any long time or efforts to maintain everything. So the next part, what we are analyzing is as soon as you start or deploy a new container, a new pod, new deployment, there's a new pod starting. We connect to the pod. Let me just select a couple of pods here. Yeah, here. When a new pod is starting, we see it. We get a message directly from the API server of the Kubernetes system. Then we connect to each and every running container inside of those pods. We detect which base operating system is running inside of it. Here you see it's a Debian 11. We perform some basic CIS benchmarks. In this case, just a couple of checks. You see the results, and of course a CVE scanning. And in this case, as I said, in the live running container. And for each and every container which starts in the cluster, we connect to, analyze the file system, and you get all those details. And here you see even here a couple of vulnerabilities could be already remediated. You have a lot of different things, packages, Java, .NET Core, Perl, Python, all those objects and libraries gets analyzed, and you see exactly those details. So for that reason, as we said before, for the topic, verifying the security of your cluster, it's really easy. You deploy that solution, New Vector, and you get all those analysis, security analysis just for free. So that was something of the inside of the live running system. And the next thing, you can even scan all your images saved in a container registry. Here for this purpose, we typically support almost all available registries. Can be online, can be locally installed. Everything what is compatible to a Docker registry API version 2. And this, for example, is a Harbor registry as well. So you can connect to, we can scan it, and then you see all the scan read details of those of those container images. I don't would like to go into too much detail here, but you can scan everything in the image registry, and you can even use this scanner directly to integrate into your build pipeline. For example, as Jenkins. So as you build a new container image, you scan it immediately before pushing it into your registry, and then you can even define some thresholds. Let's say if we have more than 5 high vulnerabilities, breaks a build. If it's below that threshold, everything is green, and your build was successful. So now let's step back, and as Holger already said, what we are doing is we analyzing the whole network stack inside of the Kubernetes cluster. Let's wait a second until this shows up. Yeah, so every single symbol you see here, for example, all the nodes in my cluster, I do have a couple of pods running and so on, and the blue lines between those objects are the network traffic, what was already analyzed on layer 7. So what we are seeing is inside of the system, we are sitting directly on each and every worker node, and we are connecting through standard kernel APIs, reading what are the network interfaces, and from the Kubernetes API, we know all the pods, their IP addresses, and so we can know exactly which network interface belongs to a specific pod. And then we analyze the network traffic. Here, for example, if I click on that blue line, you see the result. So we were able to analyze on layer 7, there's HTTP traffic going on, or WordPress traffic. And the blue lines are everything seems to be okay. We have a couple of others. Let's see if we find something special. Here's HTTP traffic. Just would like to switch in a different cluster. Just would like to look for other network protocols. No, not too interesting here. Let's see. And as you can see, I can switch between different clusters because here I do have a multi-cluster feature enabled. So I can easily manage from one UI all those different clusters. Okay, here, for example, we have a cluster with a couple of red lines. And the red line, here you see we discovered maybe something suspicious, a network traffic which was not according to the network rules we learned, and we hit here an action deny, and this means we dropped these network packets. So we just blocked this network communication. Here, for example, a different thing. Let's just would like to just select the right line. Yeah, here, for example, you see that's a good example because you see one traffic, HTTP everything was okay. And here, for example, it triggered some network attack where we are already able to detect it and then an alert, but it was not blocked. And as Holger said before, typically the software is running in an analyzing mode, so at discovery mode. And in that discovery, we are learning the normal behavior of such a container. And the normal behavior means in terms on what process is running inside of a container, what network communications is going on, and what network protocols are used. And later on, you can switch in the so-called monitoring mode, where we only analyzing the network traffic and everything what's happening, but we don't learn new network rules or process rules. We just comparing the new behavior to the learned rules. And so we are sending, if we see any deviation, for example, a new process is starting in a container where there's no rule for it, we are sending an alert, we're triggering an alert, and you can even send all those alert over syslog protocol directly to your theme system. So you know exactly what's going on in the cluster if something bad is happening. But in discovery mode and monitoring mode, NuVector doesn't block anything, doesn't kill a process, doesn't drop any network packets. So it's totally safe to run up to monitoring mode. And later on, when you are 100% sure your rules are in place, everything is safe, you can switch a couple of your services into so-called protect mode. And in protect mode, when we see an unknown process where there's no rule for it, we kill this process. If we see a network communication or a new network protocol where there's no rule for it, we block this. And this is something how you can really easily lock down the behavior of your applications to everything where you say that's known, that's okay. And as soon as something bad is happening, NuVector is able to detect it, alert it, and then later on we can we can block those operations as well. So maybe let's go a little bit into the network policies. No, let me elaborate a little bit. What we are doing is we analyze all the network traffic on layer 7. And this means we are even able to look into the network payload itself. And for this purpose, we have two specific features also, which analyze the network payload. One is data loss prevention sensors, and the other thing is web application firewall sensors. And in this case, you just define, for example, over a regex pattern, how a credit card number in the clear is built up. And as soon as you add such a sensor to a specific payload, and not payload, to a pod, you get a trigger or an alert as soon as NuVector is able to detect a credit card number in the clear inside of the network payload. In protect mode, we send an alert and we block this operation. And the same goes for web application firewall sensors. Holger already mentioned one popular attack vector. This was log4shell or log4j. And this is also something you can directly detect inside of the network payload. And in this case, you have a string pattern, which can be detected inside of a HTTP header. And as soon as we are able to detect this log4shell or log4j attack inside of a network session, we are sending an alert in monitor mode, or we block this network session in protect mode. And this means if you have a web shop based upon a Java application, which is affected by log4j, you can protect it easily with NewVector, create a WAF sensor, attach this WAF sensor, put it in protect mode. And from now on, all, let's say, a normal user, which is collecting anything in your web shop and buys some stuff, is just working because these sessions do not trigger the alert, but only an attacker for creates such an attack, sends an HTTP request, it triggers our WAF sensor, you get an alert in your SIEM system, and NewVector is blocking exactly this single network session. So this means your web shop is still up and running. It's working, it's live, you can earn money out of it, but all the attacks get detected, alerted, and will get blocked immediately. So I think this was a good overview about how you can use a tool like NewVector to analyze the security status of your Kubernetes cluster. In terms, we are looking into just doing an analysis. Is your Kubernetes system safe and out and free from well-known CVEs? The same on the worker nodes with CVE scanning and compliance tests. The next thing about scanning containers, and the best part is really about analyzing the network traffic on layer 7 and doing really a live prevention of any container hacks through additional processes, through something else like, and with this technique we can even protect you against zero-day attacks. Okay, let me stop here right now with the live demo. And let's switch back more into a Q&A session.
Dieter, I saw a question, what is the difference between NewVector and Harbor?
NewVector is a security tool, and Harbor, it's a registry. It's a container registry where you are storing container images.
And NewVector supports Harbor.
NewVector supports Harbor, so we can directly scan images which are located and stored inside of Harbor. Yeah. And as I said, we do support all different kinds of container registries.
One more question was, what is the added value in comparison NewVector and other tools like Trivi, Istio?
Okay, let me a little bit. Trivi is a scanner for container images. Trivi can be used inside of your build pipeline, and it can be used to scan images which are stored inside of a container registry. But Trivi doesn't have any, let's say, features like NewVector to scan live running containers or to analyze the network which is going on inside of the Kubernetes system. So that's about Trivi. The next thing is about Istio. Istio is a service mesh, and a service mesh adds a couple of features to your Kubernetes system. So it helps you to make sure that the communication between two parts will get encrypted. So you can think it's a kind of security, because from now on nobody can break into the network traffic from the outside. But the point is, what is when your container itself is already infected by a CVE and a hacker acting from inside of your container? Then this hacker is inside of the Istio network, and it can't be detected from the outside. But it's not a real, let's say, it doesn't protect. So Istio doesn't protect you against any insider attacks. And here New Vector comes into play because New Vector is even able to analyze the network traffic inside of encrypted Istio traffic, because we are sitting inside of the pod, so we can even see the original container traffic which flows from the application container to the Istio sidecar. So we can analyze it, we can protect you against attacks, and for you it's the best, let's say, best visibility and best security product on if you are talking about network. Any other questions, Holger?
I see. Do we have list of controls which are required for security review of container? But I don't understand what is meant by that, or what is it?
Yeah, maybe if so typically if you would want to deploy New Vector in your Kubernetes clusters, you do need a couple of privileges for some of the containers, but everything can be written in or can be read inside of our documentation. I think this was a
Yeah, I've published the link to our public documentation, but that's not
yeah,
working
please
in
do.
the chat. So maybe you can use
Okay.
it afterwards. Yeah.
Yeah, but the cool thing, the whole software is open source, so you can directly access it. You
Yeah.
can install it, you can easily deploy it in your Kubernetes cluster. And as I said before, it works in each and every, really in every Kubernetes environment. You can use it on-prem, you can use it in the cloud. So typically deploy time is 10, 15 minutes, that's all. And the easiest way doing it by Helm chart. So anything else?
Yeah, it looks like we've been receiving some questions in that Q&A box as well throughout our program.
Okay.
So this one at the top, it says, is it possible to track blocked or dropped traffic by network policies?
So you have to see, New Vector doesn't use network policies from the Kubernetes system. So what we are doing is we are learning the rules by ourselves. We are creating network policy rules inside of New Vector, and these get checked or verified in monitoring mode, and it gets enforced in protect mode. And the cool thing you can and as I said, you're not required to switch everything in protect mode. So you can use this for each and every deployment. You can select the mode if it's discovery, monitoring, or protect mode. And you have to know in protect mode, we do need more resources, more CPU cycles, and we introduce some latency because we have to receive some network packets, analyze it, and then later on when we decide it's a good traffic, so we will send it to the destination, or if we see something is wrong, we drop the packets. So in this case, you are able to select which pods to switch in protect mode, and we recommend doing this for those pods which are, I would say, connected to the outside world, or which are handling sensitive data. Not for everything. So typically 90% of the pods are running in discover or monitoring mode, and a couple of the pods in the cluster will get run in protect mode.
Perfect. Is this similar to a compliance or to compliance scanner?
I would say no, because what we are doing is we're analyzing everything directly in a Kubernetes cluster. And in this case, new vector has to be installed inside of the cluster, and we analyze everything from the inside out. And as I said before, a little bit like a complaint, a little bit, yes, because what we're doing compliance check with CIS benchmarks, we do these CVE scan things, but the main feature of new vector is really analyzing the runtime, seeing the behavior of a container and detecting if something suspicious or abnormal of a behavior can be detected. And these are things where you can even block from a zero-day attack.
So to kind of translate this into the business terms, where is the most value added from using this tool?
I would say if you deploy that, it gives you immediate insight about the security status of your cluster. You can do these, of course, with other tools, but if you see how easy it is to get all those details within just minutes after deploying it, I would say this is really a great benefit. That's the first thing. And the second, I would say main differentiator is really analyzing the network traffic, doing these runtime protection things, and blocking against zero-day attacks. So what we are doing it's really a concept of implementing zero trust.
Yeah. And you don't need to change anything, because I saw also the questions if you need to install agents, we do need nothing. So you just need to upload or deploy new vector and it just works.
Yeah, and from a technical standpoint, new vector gets deployed like any other application inside of a Kubernetes cluster. It's a Helm chart. You start a couple of pods, containers, and then we're analyzing everything. So we don't change anything inside of the environment. You don't have to change any line of code. You don't have to inject something into your containers. You don't need a special crafted kernel module installed on all the worker nodes. So it's really easy to deploy. We analyze everything inside out. It sounds like magic, but it just works. And if you don't like it, just remove the deployment and it's gone without any leftovers in the cluster.
So we're getting a lot of questions from our audience. So to everyone here, thank you so much for sending these in. This next one reads, how do we identify malicious behavior of the application? Do you have any specific experiences?
Yeah, let me elaborate a little bit of this. So as I said before, we are learning the normal behavior of an application. And what we are doing is we're analyzing what are the processes running inside of a pod. We are learning what about the file access of this application. And we are learning what about the network communication in terms of the source and destination, what is the network protocol on layer 7, and so on. And then when we switch to monitoring mode, we lock down this learned baseline. And as soon as we see a difference, so we see a new process running in the pod, or we see a process is accessing the hosts file or the password file, we immediately create an alert. Same goes for additional network communication. So think about you have a database application, which should also or only be accessed inside of your cluster from a specific pod, and let's say only with with the Oracle DB protocol. And suddenly you see an additional process like curl is starting in your container. This curl process reaches out to the internet and calls google.com. And then you see an HTTP traffic with downloading data or uploading data. So what's suspicious here? First, an unknown process. And the next is the creation of an additional network communication. And both can be detected by NewVector. And in monitoring mode, you get an alert. In protect mode, we can block those operations easily.
All right, so it looks like our questions have kind of come to a stop, and we've lumped as many as we can to address as many. Oh, does it mean that new vector operation is based on machine learning?
No, it's not it's indeed not a machine learning. We call it behavioral learning. So as I said, we just look what happens in the container in terms of file access, in terms of processes, and in terms of network communication.
Baselining is the key word, I
Yeah,
would say.
baseline is a keyword, yeah.
Understood. Well, so we've kind of exhausted our questions for right now. We've got a few minutes left. You guys want to take us through how we can participate in new vector? Or I know we've got a couple slides left here.
Holger,
Yeah.
would you like to overtake?
Yes. So as I said, our documentation is public. Yeah, here's a link. I hope it's big enough because I saw some people complaining that the screen is too small. As well, the images are available on Docker Hub. You can only download it, put it on your registry and deploy it. The same counts for the community. I saw the question about roadmap. We don't publish roadmap, but if you're participating in our public community, you can ask about feature requests, what's going on. Or if you are using it, you can also let us know what you would like to have next, and that's it.
Yeah, and these details you can find in the slides, and I think the slides are available. Holger, Cody?
I don't know, handouts. We have a tab handouts. Is it possible to download it?
So what we can do is we can distribute the slide deck to everyone after the fact, since we don't have them available right now. So Holger, if you'll send those over to me afterwards, I'll make sure we get that sent out to everyone.
Okay. Yeah,
Yeah, because then you find all the links inside of the slides.
Perfect. So with us having about 8 minutes remaining, I do just want to give each of you the opportunity to address our audience with any final remarks or any final words of wisdom you might have for them. Holger, do you have anything in mind there?
Sorry, I saw about costs, an additional question. How much would it cost on 4 times 27 nodes clusters? That is, I can't answer that question exactly. We have a bandwidth pricing, so every worker now counts, nothing else. And it's 4 times 27, it's 108, if I'm right. And so you have to calculate, and you will get a price for 108 worker nodes. And it's a yearly subscription fee or 2 or 3 years, like you would like to have.
All right, Dieter, do you see anything, or you have anything you'd like to close us out with?
Yeah, as I said, the easiest advice is if you're interested to get a really easy security tool for your Kubernetes system, test out NewVector. It's just easy to install. Try it out, see what you can get out of it, and have fun. Thanks.
Perfect. Well, I'm going to go ahead and start taking things down. So Dieter and Holger, thank you both so much for joining us today. This has been such a great program with the demo that really took us in and showed us how everything works. So thank you so much for all the time, the effort that went into putting together this presentation and sharing your expertise with us today.
Thank you to everyone for the interests. And yeah, so if someone would like, I saw already some connection requests on LinkedIn, please ask, and we are happy to help out if there are further questions.
Perfect.
Okay. Yeah, thank you.
Thank you.
Awesome. So just final reminders, this session was recorded. You will be receiving an email with a link to access the on-demand recording, or of course you can find it living on the DevOps website. Just visit devops.com/webinars and you'll find it living in the on-demand section. The 4 winners of our $25 Amazon gift card drawing are Keith D, Chanel I, Kai B, and Jacob J. So to our 4 winners, keep an eye out for an email from me. I'll be reaching out to you soon to get this gift card over to you. If you don't happen to see that email, check your spam folder just in case it happens to be filtered out. I want to thank SUSE for sponsoring our program today. And to everyone still hearing my voice, thank you so much for sticking around with us. We have a link to our survey in the chat, but if you stick around, you'll be funneled right into it. We would love to hear your thoughts about today's program, or if you have suggestions for future topics, please do let us know in that survey. We would love to hear your feedback. Either way, we hope to see everyone at a future Techstrong Learning Experience. Have a great rest of your day, and Dieter, Holger, thank you both so much once more.
Thank you too.
Okay, see you.
Thanks.